All right, we're going to start section 7.2.4 right now. The first thing we're going to look at is, have you noticed that there's a log button on your calculator? So if you look right here next to the 7, there is the log button. But when you push that log button, there's no base that shows up. So what we're trying to figure out right now is, what is the base for that log? So we're going to write it as log base question mark, we're trying to figure it out, of x equals y. And so if I convert that to an exponential equation, that would be question mark to the y equals x. So what I'm going to try and do now is I'm going to try and look on my graphing calculator and make a table. I'm trying to get integer y values to come out. So if I did log of, say, -5, I get no solution, no non-real answer. And if you remember the graphs that we graphed the previous lesson, there's an asymptote on the y-axis, so it's never going to equal a negative x value. So therefore, I'm going to start with, let's just say 1. Log of 1. Log of 1 is 0. 0 is an integer. And so therefore, I have my first point. When I would write this in exponential form, though, I'd have question mark to the 0 equals 1. Well, that doesn't really help because anything to the 0 power is 1. So what I want you to do is take a moment, see if you can plug other numbers in for x and see what the next integer y value you can get out is. All right, so hopefully you found that the next integer y value would have been 10. When you plug 10 in, you get 1. Can you find another one? When you plug 100 in, log of 100, you get 2. So 100 is 2. And so let's see what this would look like. This would be question mark to the first equals 10. Well, what to the first is 10? Ooh, question mark would have to be 10. Let's see if that fits for the next one. Here we'd have question mark to the second equals 100. What to the second is 100? 10. So we are now confident that our question mark is 10. So, bottom line, when you see a log without a base, the base is 10. I put an exclamation point there. It's very exciting. All right, so some log properties. Here, if I have log base a of 1 equals blank, here I'm saying a to what power is 1? A to what power is 1? Well, anything to the 0 power is 1. So if you have log of any base and it's of 1, that's always going to be 0. And if you look here, log of 1 was 0. So it doesn't matter what your base is. If you have log of any base of 1, your answer is 0. And again, the reason is because a to the 0, anything to the 0 is 1. If you look at next one, if I have log base a of a, if we think about our circle here, this would be saying a to the what equals a. Well, that'd be 1. So if you ever have a log of a base, log base, and inside the parentheses is the same number, it's always going to equal 1. Here the base was 10, our input was 10, it equals 1. Again, the reason being because a to the first is equal to a. If we look at it, 3, here I was saying log base a of a to the x equals what? So again, if I'm rewriting this, a to the x equals a to the x. So that would have to be x. And this one would be x. Bottom line is, if you ever have a log of a base and an exponent of the same base, they always cancel each other out. So here we are, our base of our log, the base of our exponent, they're going to cancel out. You're left with just the x. Here we have a base of an exponential and a base of a log being the same. They just cancel each other out. All right, and then number 4, if log of a, log base a of x equals log base a of y, well, the left side is the exact same as the right side. There's an equals 2 sign, so that means x must equal y. And again, if the base is not written, the base is 10. That's what we just wrote up here. And the next one says, explain why log of 6 must be between 0 and 1. So, again, this is log of 10, log base 10 of 6, and that would equal x. If you write that as an exponential, this would be saying 10 to the x equals 6. So they're saying, well, why does this answer have to be between 0 and 1? So we'll say the answer is between 0 and 1 because 10 to the 0 is 1 and 10 to the first is 10, and we want our answer to be 6. 6 is in between 1 and 10. All right, so now logs are actually a parent equation. So we're going to look at that right now. How do we transform a log? So just transforming logs work just like transforming the 8 other parent functions. Write the general equation for y equals log base b of x. And again, the general equation is the one with the h and k. So remember our general rules of this whole thing. The a always goes in the very front, and you're multiplying it. So I'm going to have an a in front times log. And this is going to be base b, because our base can be anything. Remember, the h is always with the x, and it's always x minus h. So I'm going to have x minus h in parentheses. And then our k is always out there by him or herself at the end, plus k. So that's our graphing equation. And it says, what is the equation of a graph with a base of 3 that has moved 4 units to the left, 2 units up, and vertically stretched? Where is the new asymptote? So remember, 4 units to the left would give you an h value of -4. Up 2 would be a k value of 2, and a vertical stretch is an a value, anything greater than 1. So I'm just going to make it 2. So as I go and plug this in, my a, we said was 2, or anything greater than 1 would be fine. Log, the base they told us to use is base 3, x minus a -4, so that'd be plus 4, and then plus 2. And then the question asks, where is the new asymptote? Well, the new asymptote, the asymptote's normally at x equals 0, and now we're moving it left 4. So it'd be at -4. So your asymptote is going to be whatever your h value is. So the asymptote is at x equals -4. If you remember the exponential, the asymptote was the k. So for its inverse, the asymptote is the h, the opposite. All right, and it says, what's the equation of a log graph with the base of 5 that is flipped over the x-axis, moved right 1 unit? Where is the new asymptote? So base is 5, flipped means our a is -1, and 1 unit to the right, our h is 1. So our equation would be y equals negative log base 5 of x minus 1. And again, we said our asymptote is the h, so our asymptote is at x equals 1. All right, so now we're going to look at graphing a few of these. So it says use your graph of y equals log base 2 of x from yesterday to graph the transformations, find the domain and range, and identify the asymptote. So our table for y equals log base 2 of x that we used on page 29, here's the log base 2 of x table. So we had negative 2, 1/4 negative 2. And I'm getting this from page 29. 1/2 negative 1, 1 0 2 1 4 2 8 3. All right, so let's start with B for right now. So for B, this is going to be moved down 3. So all I'm really doing is taking all of my points from this table and moving them down 3. So I had my original point at 1/4 negative 2. That's just moving down 3. So I'd be at 1/4 negative 5. My original point was 1/2 negative 1. I'm moving that down 3. My original point was 1 0. I'm moving that down 3. My original point was 2 1. Moving that down 3. My original point was 4 2. Moving that down 3. So in this case, my domain is not going to change as the parent. The parent it's still getting close to 0, going forever. Our range is always going to be all real numbers, negative infinity to infinity. And since we didn't move our graph left and right, our asymptote is still at x equals 0. I'll look at letter C, and then we'll come back to A shortly. All right, so for letter C, now that is the h value. So now we're moving it to the right 3. So again, now I'm just taking all my points from this table and moving them right 3. So my first point was 1/4 negative 2. And I'm just moving that right 3. So it's 3 and 1/4 negative 2. And then my next point was 1/2 negative 1, moving that right 3. So 3 1/2 negative 1. And then we are at 1 0, moving that right 3 would be 4 0. And 2 1, now be 5 1. And then our last point of 4 2 would not fit anymore, but it would be around over here. Again, it's also a good idea to draw your asymptote in beforehand. I probably should draw my asymptote in first. So my asymptote is normally at x equals 0. I'm moving that right 3 as well, so my asymptote is now right here. So my domain does change now. It's getting really, really close to 3, but not touching. So 3 is less than x, which is less than infinity. My range does not change. That is still all real numbers. My asymptote is now x equals 3. All right, let's take a look at how we do the stretch. So the stretch or compress works the same as it had before in all the other parent functions. Remember, whenever you have an a value, you multiply the y values by that a. So I'm multiplying all these y values by 5. There is no movement to it. It's just going to be stretched. So now I'd be at negative 10, negative 5, 0, 5, 10. So I'd be at 1/4, negative 10, be all the way down there, 1/2, negative 5, 1 0, and then 2 5. And so it is much more stretched out. It doesn't even kind of look like the original parent function because it's so stretched out. But that's what you'd have. Your domain wouldn't change from the parent, so that would still have your asymptote at x equals 0, so it's 0 is less than x, which is less than infinity, and again our range is all real numbers still. So I want you to try D and E on your own. You should hopefully be able to do that. And then we also need to add the log to our parent graph toolkit. So hopefully you can see this. But this is what we're going to have for our toolkit. So our log, or logarithm, log for short, our log base 2 table is given to us. That's the one we just wrote down on the previous page. And when we plot that, this is what we get here. Our parent graph would be y equals log base b of x. Our general equation is what we just wrote down on the other piece of paper. Y equals a log base b of x minus h plus k. Our domain, we talked about it being not touching 0 ever, getting really close but not touching, and going to the right forever. And our range being all real numbers. And then our properties is that it grows very slowly, and it is the inverse of an exponential. We also probably want to put on there, actually we just have to scroll down and this will be on here, that description of HK. Now, again, like I said before, there is no K value. That's part of our key points. But the H is the vertical asymptote. Okay, so the K still does move it up and down, but it's not going to be on the graph. Again, so the H is the vertical asymptote. And that's everything you need to know about logs.